Okay guys, after all this theory, now let's have a look into a practical exercise. Let's start exploiting those activities. Are you ready for this? Let's switch back to the Ubuntu VM. Okay, back at the Ubuntu VM, we go back to an application which we have already analyzed a little bit. I'm talking about the Thief application, which has been developed by MWR Labs, which is now F-Secure. So this is a really amazing capture the flag application, and this is where we are going to practice our knowledge right now. So therefore, let's go. Okay, as always, you can find this application as an attachment of the section. So I've already downloaded it and it's over here. Okay, so the first thing we want to do is we want to install this application and verify that it's working on our device. Which device? I'm using the emulator, but you can also go for a real device. So this should work perfectly fine. Okay, so let's see which emulator I've got. Emulator, list, AVDs, and there we have it. Nexus 6, RP level 30. I will keep repeating this pretty often in this course, so sorry for this if you have heard it now multiple times. But yeah, regarding to those emulators, the Nexus 6 device, it's in my opinion the best one. It's not that powerful, which is good, because this means it doesn't require a lot of resources and is therefore not as laggy as a Pixel device, which might require a lot of resources. Alright, so let's start this one. Emulator, and then we simply provide this name. So the emulator is starting and we already get this warning. Running a nested virtualization, it's not a good idea, but even within this virtual machine, it works perfectly fine. So, okay, maybe not perfectly, it's a little bit laggy, but not as bad as you might think right now. You can also use a real device or our x86 approach with our external virtual machine, no problem. So here we have it, let's start it. Okay, perfect. Now device is running, so let's go back into our application directory on Thief and let's install this application. It's hanging a little bit. Okay. So here we have it right now. Let's start it. And it's loading. And we already get this message that this application wants to access our files and media. And this is something we definitely need to take care of. Not regarding to privacy, more regarding if we are analyzing an application, then we should figure out what this application is doing with those files. For example, might there be some access to the SD card and public available directory where some sensitive information could be stored, things like this. So if we're dealing with some permissions like this one over here within a penetration test, we should figure out what is being done with those permissions, and maybe we can exploit this stuff. Okay, for now we do not go too deep into this, we just want to focus on those activities. So we grant this permission. Okay, and here we have it. So the fan is spinning a little bit. I hope it's not that hearable on the microphone. Okay, so here we've got it right now, and there's the warning. This app was built for an older version, but don't worry, I have tested it on an RP level 30 device, which is Android 11, I guess. It's working perfectly fine there. So simply click OK and we're good to go. Okay, we have already talked about this application and therefore I do not want to extend this video unnecessarily long. In Thief, it's a capture the flag password manager, so we can provide a password over here, which will be used to encrypt and decrypt our passwords stored in this application. Okay, so that's the whole functionality about Thief. Okay. So let's fill this out real quick, and therefore I'm using the ADB shell and I'm using input text, and we provide a 16 character long password. And there we go. And we can see normally we should use alphanumeric digits, capital letters, and at least 16, but we can simply use 16 numbers. This would be already in finding if we have this in a mobile application. If it recommends to use this character set, but we can move on with this one. So let's submit. Okay, password seems to fit. I mean, we can see it over here. Then we cannot make mistakes typing in it. Fun fact, by the way, if you're having things like this in PIN, for example, and you enter this, yes, those numbers appear over here. So I was once sitting in a presentation where someone did enter a password via a form field on the presenter. So everyone could see the password, even if there are dots. I mean, the character is visible for a certain amount of time. So it's not a good idea to do this, but over here it's fine. You can see my passwords. So now we have to provide a PIN, and this PIN will be used to access this within a quick mode. So if you put it into the background and opening it once again, then we only have to enter a PIN if we have already decrypted the database with this password over here. So let's define a PIN. Okay, we submit this. And now we have to enter the password. So we have an initial setup right now. Okay. We should keep in mind what we are seeing right now because these are all activities. So we had an activity regarding to a PIN. We are also having a password, an activity regarding to entering a password and things like this. So if you browse an application, we have now to see this through the eyes of an attacker. So we have already seen a few activities. All right. So let's insert our password here. Okay, sign in. Okay, now we've got another activity, so that's a different screen content. And over here we've got settings. This is another activity, all right. We can change PIN, delete passwords, backup to SD card and things like this. And over here we can now define a new entry. So let's do this. Add new password. We have seen another screen has been opened, so this is another activity. We've got tons of activities in here. So let's say this is our banking application. The username is app hacking and the password is super secret. Okay. And save. Now we are back in our passwords activity and there we have the entry added. Okay. So now we can see this is our banking entry and if we click on this, the password will be copied to the clipboard. Okay, so this is our password manager. And on the first view, it looks decent because if we close this application, or let's say if we put it into the background, and if we are opening it once again, what? No recent items. So let's see. Okay, there we go. So if we are opening it once again, we do not get access. We have to enter our PIN. Okay, if we do this, then let's see. Okay, then we are in. And if we close this application, we have to enter the complete password. So let's see. Yes, so here we can see we have to enter the password. Let me check something quick. If we are entering a wrong password and try to sign in, password is incorrect. Let's see if we could brute force it. Yes. It would be generally possible, but having 16 characters, even if these are just digits, it's not really practical. The PIN approach, that's a different story. So the PIN consisting of 4-digit numbers means we are having 1000 possibilities, 10 square 4, and this would be possible to brute force, but not a 16 character long password over here. Okay, now finally, let's start hacking this application. So let's get back of the ADB shell and let's start analyzing it. Our reversing methods are limited right now. We have a complete reverse section where we go through analyzing an application based on the source code. So maybe a little bit of a spoiler. If we are using JDX-GUI and opening this APK file, then this tool is reconstructing the Java code out of those classes.dex file. So here we're having now Java code. Let's open something. For example, this activity. So here we can see the code. But this is something we cannot do right now. We will talk about this whole approach in the reversing section. I just want to show you already that things like this are possible. I mean, this is not the original Java code. It's an interpretation of the original one, but it's pretty close to the original one. So we get a few errors maybe from methods that could not be decompiled, but the rest, I mean, it's pretty decent. At least for reversing, it's well enough to do this. Okay, but as already mentioned, not an option. And that's still not a problem, because what we could do or what we want to exploit are now those activities. And where do we find those activities? Absolutely correct, in the Android manifest XML. And how do we get this file, the decoded version? Absolute correct too, with the APK tool. So let's use the APK tool, on our Sieve application. Okay. Now we can see decoding Android manifest with resources. All right. We are also decoding a little bit more, but I mean, that's okay. Here we have now the directory and here we have our Android manifest. And let's see We're opening it with Vim. Yes, here we have it. Absolutely beautiful layout, but let's not do this on Vim. So if you're now stuck at Vim, don't worry. This is, I guess, or this was the most asked question on Stack Overflow a while ago. You can simply go back by hitting escape, :Q and exclamation mark to force it. So this is the way to exit Vim. In case if you didn't know this, this is an absolutely lifesaver for you right now. Okay, we're not opening it with Vim, we are going for the Visual Studio Code approach. Okay, so it's being loaded and here we have it. We can also select word wrap. Then we make sure that every line will be visible. In case if it's longer, then it simply gets wrapped around. Okay, we have already analyzed this application file within the Android manifest XML. So in case if you haven't watched this video, I mean, it's good to have it because there's a lot of interesting stuff over here. Like for example, these custom permissions. But we're not going to do this right now. We only want to focus on our activities. So we simply focus on those activity tags. No services, no content providers. We are only focusing on the activities right now. Later on, don't worry, we will also exploit them, those new components over here. But for now, yes, let's focus on this one. So our first activity we've got in here is let's see, the file select activity. I mean, the name could be everything, but most of the time developer name their things like the things they are doing. So in this case, we might have an activity where we can simply select a file in there. The most important part is this activity being exported. So let's see. Maybe let's do it in this way and zoom in. Okay, we zoom out. That's not good. Here we have it in one line. So Android exported true. Perfect. So this means this file select activity is being exported. And this means we can start this activity from the outside world. We could write our own application, which is sending this intent to start this activity, or we can use the ADB shell to do this. We will use the ADB shell and maybe at the end have a quick bonus section on how to write our own application to exploit this. But for now, we do this on the ADB shell because this is pretty easy in there. All right. This means we can start the file select activity. Okay, what else can we do? Then we've got this activity. That's the main logging activity. And the question right now, is this being exported? So please think about this at least for a few seconds and pause and rewind this video. Alrighty? Okay. So here we are back. And the answer is yes, it is being exported because we have this intent filter. So this application, maybe let's get some graphical output over here. In this application, let's see if I can draw this with a mouse. Yes, I guess that's pretty good. Oh, that's decent. So that's an ear, in case if you haven't seen this right now. So this activity is listening into the smartphone, and this one is waiting for an intent. And this intent needs to have the action main and the category launcher, which means that those two operations will be triggered if we click on the icon of this application on our smartphone. Then those two, this action and this category, will be sent for our application, and we're listening to this event right now. So this activity is listening when those events appear, and then it's starting this one, the main logging activity. And this is our entry, our screen entry, so our entry point of this application, which we see over here. This is our main logging activity, and this is how the intent filter is working. So we have registered our intent filter to listen to those two events. Alrighty? Okay. Having an intent filter means we're having an implicit exported, which means this main logging activity is also exported, even if it's not being defined like this one. Where do we have it? This one. Exported true. So both of them are being exported. Explicit, implicit. Alrighty? Perfect. Then let's see. We've got this activity, which is pwlist activity. Is it exported? Yes, it is also being exported. And if we search for this one, I mean, we can shorten this path right now. We can see we have this one, file select, pwlist, And those two, these services are also exported, and the the content provider, that's a content provider, is also being exported, but we skip them for now. We will analyze them later. Okay, here we can see nothing of them are being exported. We are not having these settings, add entry, short login, interesting, welcome and pin activity, none of them are being exported. Okay, so this means we could possibly attack the file select, PW list, and theoretically also this one, but I mean that's the launching activity, so it would be ridiculous if we are having a vulnerability in here. Okay, now's the question, how can we start an activity? So how can we tell the smartphone or this application in this case to open the file select activity? We could write our own application, or in this case we are now using the ADB shell because that's the most easy way to trigger this event right now. All right, so let's have a look. We are opening a new terminal, we put this to the left and we go into the ADB shell. So the weapon of choice we are using right now is the activity manager, and we can open this with AM. All right, the activity manager there's a lot of stuff in here because the name is a little bit misleading. It's not just regarding to activities, we could also perform actions regarding to services or broadcast receivers. And this help over here, this one, is being defined into two parts. So at the beginning, this help might be a little bit confusing, but once we have figured it out and we are doing this right now, then we will have no problems anymore with this one. Alrighty? Okay, so let's see. On the first half of this activity manager, we got lots of options. We can see we've got this option start activity. Perfect, this sounds exactly what we want to do. And we have a lot of parameters in here. Start profiler, use, let's see, -- user. Is it regarding to which user to run as? So we can define another user which we want to start this activity. We can enable debugging, native debugging. We can wait for launch to complete and things like this. So we could start an activity and say, okay, wait until the debugger detaches or attaches and things like this. But we do not want to do anything of this. We just want to start our activity and that's all. Okay, so we are using AM, Activity Manager, start activity. Let's type this in. Okay, now we need to define which activity we want to start. And if we go upwards, back again, we cannot find any information about this one over here. We can see we also got start service, broadcast, so interacting with broadcast receivers, but we cannot define which activity we want to start. This is now in the second half. So in the second half of this help, we will find this intent declaration, this one, and here we have now all the necessary information. So we need to have a look at the beginning to figure out what we want to do. Just let's say a basic task, starting an activity, interacting with a broadcast receiver or with a service. And in the second half, we have to define our task right now. Okay, so let's see. In the second half, we have now things like action, data URI, or category. We will talk about them later. So this is something which is important in the intent topic, which we will have next. But for now, we can simply skip this. We are only interested in the -n option because that's the component name. And the component name is simply just the name of the activity we want to start. Of course, it has to be exported, but this is the case for us right now. If we go back, here we can see our file select activity is being exported. And now we have to address this file select activity. We need to tell our activity manager to start exactly this one over here. And this is being done with -n component name. So all we need to do is we need to tell our activity manager to start this one. And we have to reference it in a certain way because file select activity might be used quite often in applications. And therefore the Android system would know which one we want to start. The component name exists therefore of a package name, which is a unique identifier, this one over here, and then slash, and then our activity name. All right? So our component name is our unique identifier, slash, and then the activity name. And by having it in this way, we can make sure that we are exactly starting this file select activity. Not the one within another application, exactly within this one over here. Back to the activity manager. Okay, AM, start activity, -n, which is the component name. And now the package name, which is this one, slash, and then we take the activity name. So Android name, this one over here. We keep this dot is required. The quote not, but the dot is being required. Let's go back. Yes, this activity is being exported through, which means we can start this right now. All right, let's do this. So let's keep the phone on the right and this on the left, and let's do this in 3, 2, 1. Nice, awesome. We have bypassed the locking screen and we are now in the file select activity. But it doesn't mean that this one over here is already in vulnerability. I mean, yes, we are now in the select file activity, but we need to figure out what we can do right now. So therefore, let's have a look. We do not have extra buttons over here, okay? And we got this storage emulated Android data directory. So we see this path, but I mean, that's not a secret. So let's try going into this one, for example. Oh, folder can't be read, okay. And if we go backwards, then we've got files, but there's nothing in here. Okay. It could be the case that no backup has been already created and therefore this one is empty. It's therefore also good to perform all these actions in an application if we are testing something. So for now, it doesn't seem like the select file activity is doing anything for us as an attacker right now. We can also check if we can use this back button. Yes, but then we are within the enter password activity again. Okay. So we can start this file select activity, but we cannot do anything right now. Maybe because the content has not been created yet, we should go back to this topic after creating a backup. But for now, it's not vulnerability. Okay? All right. And by the way, this one over here might be also interesting. What's this one? Settings. This is already in finding. I mean, we can access the settings activity via the main logging activity. To be honest, I'm not sure if this is an intended behavior or a programming mistake. Within a capture the flag, I would assume it's an intended behavior. So this is also something we should look for. All right. But for now, okay, we're having the settings activity, but we can simply exploit this by having, by clicking on this button. And that's not cool. So let's see what else can we do. Because there was one additional activity. By the way, the settings activity is not being exported, so this is something we cannot start right now. But the PW list activity is being exported. So let's see. Whoops. AM start activity. And I'm not using or copy pasting the example or the code before, because by typing it in, it will be, we will easier remember this in the future. So it's good to not always copy the stuffs. It's good to write them once again. Okay. If we now want to address the PW list activity, we need to have the package name in front. So com mwr example sieve slash dot and this one, because the dot is also being included over here. Okay, let's see. 3, 2, 1. Nice. This is also working and this might be already in finding, because we can see right now a service inside this application. So we've gotten banking service and now let's see if we can open this. I click open and no, error. Unable to connect to the service. Force quit the app and try again. Okay, so this one over here, this is a perfect example. We have successfully bypassed the locking screen of our application by directly starting the PW list activity, the exported PW list activity. So we do not have to enter the password. We are now directly entering this activity of our application. But now we're getting an error. I mean, we can see that we've gotten banking entry, but this banking entry cannot be opened. The reason for this is, if the application starts this PW list activity, it has to start and service before. So after successfully logging into this application by providing the correct password, this application would first start and service, and this service is being used to decrypt our passwords in our password safe. The service has not been started right now, and therefore we are trying to enter this banking entry, but this banking entry cannot be decrypted because the service, which needs to be started before, has not been started. There is no service, so this is gone. And this means this application is now throwing an error because this service has not been started before, and therefore those entries are still being encrypted. So we couldn't read them right now, which means Yes, we've got an information leakage, but it's not as bad as you might think at the first view. So this example is pretty great. We could maybe circumvent this by also starting the service manually and then entering the PW list activity. But this is something we will do after talking about services, because I do not want to get into other topics right now. We have seen that this activity can be started, but we cannot fully use it because some certain states has not been configured yet, which would have been configured if we normally log into this application. Alrighty? Okay. It doesn't mean that we are done right now, because now we have entered the secure context of this application. We are now in the secure context and we have to figure out what else we can do over here. For example, let's see if we can create a new entry. Yes, okay, we can enter a new one, and we have now an add new password activity. So let's see. This one, what might this be? Add entry activity. So this is the add entry activity, and this one is not being exported true. So from the PW list activity, which has been exported, we could now also opening this activity, and this one has not been exported, but this one has. So if you're opening this one, we have entered the secure application context, which means we could also start and interact with all other components that are linked in this activity over here. Alrighty? Okay, so let's see if we can really add a new entry, because this is something we do not know right now. Okay, so here we have it. Service, banking 2, username is test, and password is 1234. Okay, now let's click save, and yes, unable to connect to the service. So once again, the service needs to be running to interact with those components. So, okay, it's not a huge vulnerability. For now, we are only getting an information leakage. But we can now also opening this one. So what's over here? This is the settings activity. And now let's imagine this activity wouldn't be available from the logging screen. So this one is also not being exported, right? Yes, this is not being exported. But once again, we have entered the secure context via the PW list. And this one can now also start the settings activity. So we can also hunt for vulnerabilities inside here. Okay, let's see what we can do. Change pin. Let's see. Let's open this one. And unfortunately, we have to enter the old pin. So in case if we wouldn't have to enter the old pin, if we could provide a new pin, then this might be exploitable. So after the user has logged in and put this application into the background, we do not require a password. We do require the pin. Which means if we are now entering the pin activity, then we could define a new password if we do not have to enter the old ones, because we do not know this right now. Okay? So this could be exploitable, but in this case right now it's not, because we have to enter the old pin and we cannot simply overwrite the new one. Okay. But nevertheless, do not give up. So let's go back. Delete passwords. Let's see. This will delete the entire database. This is something we definitely want to test at the end. So not right now, but if we could delete the whole database, this might be also pretty bad. Okay, back up to SD card. So let's see. This will save the database to the SD card. Let's do this. Let's see if this is working. Database exported. All right. So now we have exported the database to the SD card. Let's verify this. Okay, ADB shell. SD card, and let's see. Okay, let's make this larger. We cannot see it over here, which means those data might be saved in the Android directory on the SD card. And this is on modern smartphones and protected directory, which means even if we try to access the data directory, we have permission denied. Okay, we need to have root privileges to access this one, which doesn't make it in finding. But nevertheless, let's have a look into this one. Okay, we can get root privileges by simply entering SU. And then let's see. Yes, here we can already see this. And yes, the user ID of this application is A127. This A can be replaced with 10,000 because this is the entry point where our application starts. So we have talked about this in the permission section. There we will find out what's behind this user ID, which means only this user or higher privileged user can access this directory. So now we are higher privileged. Let's see. we've got this files. Oh, do you still remember this files directory? So we have seen this in the other activity, in the file select activity. So maybe we have now a file inside here. All right, let's simply print out what's inside this file. And there we go. Okay, here we have now the password and the PIN, and this is being stored in clear text in this file. Okay, so far I wouldn't count this as an real finding. I mean, yes, those information could be protected, but we need higher privileges to access this file. All right, but on older smartphones, this might be a finding because there we do not have this Android directory, and it might be directly stored on the SD card and can be accessed by every other application too. All right. Okay, so far we do not care about this. We just want to talk about activities and take a little bit left and right look into this application analysis. Okay, so also this one, it's not too bad. Okay, next we've got backup to net. Let's see. This will save the database to the server. Okay, let's do this. Okay, I'm not getting any message or things like this. And therefore, let's also open up the ADB logcat, because this is something, oops, not this one again, because this is something you should always observe. Within the ADB logcat, we will find a lot of useful information regarding to those applications. So let's do this once again. Backup to net, yes. All right, so here's the network manager and failed to connect. Okay. So here we've got the server where this application tries to connect to, but this is a topic regarding to man-in-the-middling. We have a whole chapter on this, how to get into the network connection of a device and intercepting and analyzing this traffic. This is nothing we're going to do right now, but so far we can see, okay, the smartphone cannot connect to the server, but the functionality would be given right now. And then we've got restore from SD card. Let's open this one. This will replace the current database, yes. And there we go. This is our file select activity, and now we've got this backup file over here. So within our file select activity, if you're now opening it once again, we might have this backup, and we could overwrite the current configuration with an old ones, with ones which has been backup. So this could be also a finding. So far, it's not too bad for this application. So maybe let's close this one. Okay. So far, it's not too bad for this application. So we can delete maybe those entries. Let's do this at last. So let's see. Yes. Database deleted. Okay, let's go back. Yes, okay, it has been gone. So as a user, we could circumvent the locking screen. Then we can enter the PW list activity. We could start the settings activity out of this one, and then we could delete these entries. All right, it's a finding, but I mean, it's more like a denial of service. We do not get those information right now. Also, the backup to SD card, it's not working on modern smartphones anymore, and I do not want to show you stuff which sounds absolutely amazing, but doesn't work on modern applications. So the things we want to analyze and learn right now is related to newer modern applications and not things that work on Android 4. Backup to net might be interesting if you can perform a man-in-the-middle attack and then triggering this event manually, then we might be able to fetch those information. So the passwords and things like this. So this would be a finding if we could achieve this task. We will have a look into this one in the man-in-the-middle section. Alrighty? Okay. Last but not least, we've got this restore from SD card where we can simply restore an old version. And we could also directly access this activity over here. Okay, so this is all for this video right now. I mean, it has been a little bit long just for the case that we have learned how to start an activity. But we also took a view left and right and also talked intensively about the exploitation of the stuff. We can see having access to the ADB shell, we could start an activity. I mean, that's the most easy way. And if you want to have a proof of concept, we can write our own application that performs this bypass. So I will do this in a bonus video afterwards. Okay. Nevertheless, we need some kind of physical access, because if we are bypassing the locking screen, then we need to have the smartphone in front to perform those actions, which makes it not that interesting anymore. It could be still dangerous, but it's not that fancy anymore if we have to have the smartphone in front of us. Alright, we could have additional attack vectors for our activities, which means If we have an intent, which we talk about next, then we can provide additional information to our activity. And those information might be required by this application, which could lead to other vulnerabilities. We will talk about this after the intent section, because then we know what an intent is, how to trigger and how to interact with this one. Nevertheless, the activity needs to be exported. So this should be your first view. So if the activity is being exported through explicit or based on intent filters, then we might have additional attack vectors. In case if it's not being exported, like this one, for example, the settings activity, we might be able to open the settings activity based on another one. And in case if we do not have any reference to an activity like this, for example, the short logging activity, then there's nothing more we can do right now. So that's all for now, and I'm really looking forward to see you in the next video.